So Quadrilaterals review packet. We've got some solutions here for you. So angle measures of a quadrilateral, we simply have to add them to 360. So we got 120 plus 70 plus 60 is 250, and 360 minus 250 leaves us with 110. So this is one option. Okay. Number two, since it's a parallelogram, we're going to use a couple properties. Consecutive angles in a parallelogram are supplementary. So I would say 180 minus 70 is 110. Now that gets us x. Y, what we're going to have is opposite angles. We're using this property, are congruent. And I'm going to write that down in an open response situation so that I can justify y. And of course, z is just going to be 110 because it's opposite x. Isosceles trapezoid. Okay, so what we've got here is base angles congruent of an isosceles trapezoid. So right now we can say that z is 130 degrees. Okay, and again we can use the same property for trapezoids. Consecutive angles along a leg are supplementary. Okay, so real quick, they should have told us, obviously, that those are parallel. Oops. It didn't. So we're going to assume it for a second for a trapezoid. So those are parallel, and then this would make this a leg, base, and base. Just so we know the terms. And then these two are consecutive, right? They share a side. Struggling with this here. What is going on? They share a side. Consecutive. Okay, consecutive we talked about is they share a side, but they have different vertices. So we're going to have 180 minus 130 to get 50. So x is 50 degrees, and so is y, because of this base angles are congruent. Okay, next, since it's a rectangle here, what we need is angles. All the angles are 90s. So for angle A, what we could say is 90 minus 50 to get 40. So we got x is 40. Okay. Something else that happens here. Let's see. Rectangles have the same properties as parallelograms. So we have, we'd use this one, sorry. We'd use that here. If you look carefully, it's the backwards n. Okay. So then we're going to use alternate interior angles so that z is 50. And of course, we know y is 90 because the angles of a rectangle are 90 degrees. All right. Continuing, number 5. Okay, so it's a rhombus. A rhombus, the diagonals bisect the angles. That's what we need to know here. And then it also gets all the properties of a parallelogram. So if they're saying that this is 30 and the diagonal goes through there, then x is 30. All right, that finishes this one. Now, what we can depend on here is still these are parallel. Okay, so we could depend on alternate interior angles. Since that's 30, then y is 30. And there's going to be just a little work here. There's a couple ways we could go about this. We could say that these are Uh, this is an isosceles triangle. We could use that, right? So if you have an isosceles triangle with 30 and 30, you could add to 180 and figure that out. All right, so 30 plus 30 is 60. 180 minus 60 is 120. So then, whoops, sorry, Z is 120 degrees. All right, so kind of mention what property we used. Isosceles triangle, base angles theorem. So anytime we're lacking in work, we can make up for it in, naming the theorems that we used. All right, a couple more here. This is just a trapezoid. They should tell us which sides are parallel, but I think without any information, we can assume it's these. All right, and then what we're going to base everything on is consecutive angles along the same leg are congruent. Sorry, supplementary. Sorry about that. So they add to 180. So x and 120 are going to add to 180. I'm just going to do this one just a little different just to show you an algebraic way. But if you just did 180 minus 120, that obviously gets it done as well. So x is 60 degrees, and we're going to find y. Y and 20 are along the same leg. So I would probably do 180 minus 20 to get 160. Y equals 160 degrees. All right, let's see. So we're given a parallelogram. All right, angle 1 right here is 42 degrees. So what we have is we know parallel sides, opposite sides are parallel because it's a parallelogram. All right, measure of angle M is 50. We've got a lot of good information now. MQP. Okay, this one here is 137. Let's see what else. Find the measure of MJ. Let's use, maybe we'll use a highlighter. We want MJL. All right, we want this one from here to here. And JPO. Let's see, where is JP? All right, this one here. So we want that. All right, so let's first use the idea. That's strange. All right, so we'll use this idea. What we have here, if you look carefully, I'm kind of drawing this backwards, Z. And we usually use that. When you have parallel lines cut by a transversal, so you got a 42 degree here. What we're going to use is right here is also then 42 by alternate interior angles. Okay, so angle 2, so the measure of angle 2 is 42 degrees. All right, the other piece of information that we could use is that this is 50 degrees. So, see this kind of this yellow triangle almost. You've got a 50 in this corner, you've got a 42 in that corner, that angle. And we want this one. So, we're going to add to 180. So 50 plus 42, we've used up 92. 180 minus 92 is 88. Okay, so that angle measure is going to be 88 degrees. We could use algebra, but I think this is more, understandable. So let's go over here. The measure of then MJL is what we just did, 88 degrees. All right, so that's one answer, and that's all the justification for that. It says justify. We're going to get away with mostly, maybe what we could do is say what it is. It's alternate interior angles that we used. Right, for the 42 in angle 2. Okay, so that's kind of what we're looking at there, congruent. All right, now we'll go to this angle up here is actually pretty nice. Let's focus again in on the fact that it's a parallelogram. And what they gave us was 137 degrees here. This is a straight line here. And they're wondering about this angle, but it's very easy to get this one. Okay, so this angle and this angle are, again, alternate interior angles. These two angles are a linear pair. So I'm going to use 180 minus 137 is 43. Then that angle is going to be 43 degrees. Linear pair, then alternate interior angles again. So what I'm doing is I'm justifying probably further than I need to, all right, but I want to make sure that there's no room for scoring it less than full credit. Okay, so now I'm going to say the measure of angle JPQ is 43 degrees. So leave no room for error. And that's it for the first video.